All right, so take your notes out and let's go. So this is going to be 1.2 continued. Okay. Which one did we end on? It was number 5, but it was what was a compound fraction divided by a fraction. Okay. 2/3 divided by -5/4. Okay, so we were on number 5. This is 1.2 continued. Just do a couple problems from it. And we ended on, we had 2/3 divided by a -5/4. And I don't know if I showed this part yesterday, but if you get to a problem like that and it's a little confusing, this is what we call a compound fraction because it's a fraction divided by a fraction. So you have two fractions in there. If you need to write it that way to visually see it, do it that way. And then you can go keep it, flip it, switch it. If you want to just go directly from here down to this step, that works as well. -4/5 like that. So keep it, flip it, switch it. And then, is there any cross canceling we can do? We did some yesterday, but do we have any cross canceling on this? 2 and 5, nope. 3 and 4, nope. Don't forget, positive times a negative is a negative, right? And so we go negative, and then we go 8/15 like that. Okay? So that would be the process there. Let's do this one. This is we'll call this number 6. This is Kevin's bucket contains 2.5 gallons of water. If he gives his horse 2/3 of the water, H2O, how much H2O does the horse get? Okay. A little bit of writing. You can do it though. Become a good note taker. I'm writing, you're writing. Nico!
I'm not supposed to write now. I think about it. Do it divide by 2/3, which is just multiplying by 3/2. I think.
You're answering the question.
Yeah.
Okay, just stand by when people are still writing.
Okay.
Gotta give them a chance to catch up. Are we missing anybody? I feel like we're all here. Good job for being here, guys. Way to show up. That's good. Way to show up. Okay, check with your cheat mate while you, there we go, and the data.
And then that would get you.
So Kevin's bucket contains 2.5 gallons of water. How much did his horse get?
So you know the answer's
Okay, so for starters, we have the problem written, and then for a second, we take a stab at simplifying it or solving it. put that in my mixed form. Normally I'm saying non-mixed form is no problem. So what is that in mixed form? 15/4 is, what's the mixed fraction? Not the decimal, just what's the mixed fraction? Do you know what I mean by mixed fraction?
Yeah.
2.5. Yeah, so how would you turn that into a mixed fraction? So what's the mixed fraction? You guys help me. 3 3/4. Okay. So does our answer, does that work? 3 3/4 gallons. No, yes, right, it starts with 2.5. Okay, what'd you get? 2/3. Okay, so here we go. Michaela, walk us through what you did.
Okay. I changed the 2.5 to exponent.
Okay, so change 2.5 out of mixed form into just fraction form. How do I do that? I go
2 times
2 times 2 is 4, add the 1, right? So it's 5. So Michaela said, I'm going to turn this into 5 halves. Okay, so it's a start. And then what do you do?
And then, so it's divided, so then you would multiply it and switch the 2/3.
So you said divided by 2/3.
Yeah.
Okay.
So then
So we gave his horse 2/3 of the water. So divided by 2/3. And then you keep it, switch it, flip it, and you came up with
1, 2, 3. Oh, 5, 3.
well, if we do it this way, it came up with 15/4. Right? Now, because you said divided. Now, 15/4, let's walk this out. If I do 15/4 in the mixed form, because that'll help us with our answer. Because usually if you were telling somebody, hey, I have 15/4 gallons of water, it wouldn't make much sense. Right? You would tell them I have 3 and something, gallons. So to convert this back, we go 4 goes into 15 3 times evenly, right? And then you have 3 3/4 gallons. So this would actually yield 3 3/4 gallons that the horse got. And we're like, wait a second, that doesn't make sense. Because I started with how many gallons? 2.5. The horse only took 2/3 of it, and the horse got 3 3/4 gallons. It doesn't make sense. So we reset and we say, wait a second, I have 5 halves. Should I divide by the 2/3 or multiply? Multiply by the 2/3. Let's try that. And then that gives us, so instead of dividing by the 2/3, you multiply, so you cross cancel, you get 5/3, which we then say 1 2/3 gallons for our answer. So if you started with 2.5, gave the horse 2/3 of. Now, what's the key word in there that helps us understand multiplication or division? Yeah, Leah. Yeah, right there. Ding, ding. What does that stand for? Multiplication. Yeah, so 2/3 of. So you got the 1 1/3, or 1 2/3 gallons. Okay. Okay. Side note: how many pounds? How many pounds does a gallon of water weigh? This is a side note. Yeah, approximately 8. 8.3, but 8 is a rough approximation. So if you're carrying a 5-gallon pail of water to take to your horse, it's about 40 pounds. It's a lot of water. So there you go. Okay, we are going to move on from 1.2, and we're going to go into 1.3. When is 1.2 due? Tomorrow. Is 1.3 going to be due tomorrow? No. I'm going to say no on it, but you should be able to get started on it. So let's go into 1.3 and start discussing some of that. We may get through all of it today, we'll see. So 1.3, not continued, is going to be a fresh start for us. This is exponents and roots. So exponents are a way to deal with multiplication, actually. A shorthand way to deal with multiplication. So this is exponents, and roots. Okay, and we'll go with, when we have, let's start with this. If I say 3 times 3 times 3 times 3 times 3 times 3, we can write that all out, right? So that works to write 3 times 3 times 3 times 3 times 3 times 3, you know, and that works to do that. However, what they created in mathematics is a shorthand way to write something being multiplied by itself over and over and over and over, right? And what they did is they said, hey, we can write this in what we call exponential form. And so what we would state is how many 3's are multiplied together. In this case, there's 6 of them. So the way we write this in exponent form is 3 to the 6th power. Now, I wouldn't expect you to know what that is without doing, you know, a calculator. We could do long multiplication, but we're not going to test you on what's 3 to the 6th power. Okay, so 3 to the 6th power, though, it's a shorthand way to write multiplication of the same thing. When we look at this, this is referred to as the base. So the 3 is what we call the base, okay? And then this is the exponent part. So we might say, hey, what's the base exponent, or what's the exponent part? So this is exponential notation. All right. Let's go through a couple rules of exponent notation, or of exponents. If I have, let's say, x to the 4th times x squared. So if you're going to multiply with exponential notation, if you're going to multiply these together, this is going to equal, okay, x to the something. What is that something going to be? 6. The common error, and it's understandable, is to say x to the 8, because you're saying I'm multiplying, right? And so 4 times 2 is 8. But what we remember is that if we did x to the 4th in expanded notation, this is actually what? X times x times x times x. There's 4 of them. And then how many x's are here? 2 of them. And so you have 4 and 2, which gives you a total of how many x's? 6. So a really important rule, when you multiply the same bases together, like that, you add the exponents. So the exponents are added. So in this case, I didn't show that, but what was happening is 4 plus 2. Okay, so that's an important rule. When you multiply the same bases, you add the exponents. Now, the power property is another property. So is this, if you have, draw a line here, if I have y to the 3rd to the 2nd, like this, this is called the power property because it's actually an exponent of an exponent. When you have this, okay, are you going to add these or are you going to multiply these? You're actually going to multiply them, so it'll be y to the 3 times 2, so this should be y to the 6th power, okay? Why is that true? Well, that is true because something being squared represents that it's multiplied by itself twice. So what this is really stating is y to the 3rd times y to the 3rd. Let me go like that. Y to the 3rd times y to the 3rd. And then we say, well, there's 3 y's there, there's 3 y's there, which gives me a total of 6 y's, and you can just add those together. So that's called the power rule, that's called the multiplication rule, or the product rule, product property. The other thing is that you have the quotient property, and that is this. If you have z to the 10th over z to the 3rd, let's say, when you're dividing, so we had where we multiplied the bases, we had an exponent to an exponent, now we're going to divide the same bases. What do we do with our exponents? Yeah,
Subtract them?
Yeah, you subtract them. You have z to the 10 minus 3, so you end up with z to the 7th power. And the reason for that is, if we did out the longhand, and maybe I should have chosen some smaller numbers, but we would have 3, 4, 5, 6, 7, 8, 9, and 10. So you would have 10 z's all multiplied together, and then you would have 3 on the bottom like that. Okay, so 10 on top, 3 on the bottom. When you go to divide, right, z divided by z. What is z divided by z, by the way? A lot of people say it disappears or goes to nothing. That's not true. What does z divided by z go to, Zach? 1, yeah, so that's 1. That's 1, and that's 1. So there's the number 1 is actually in the bottom. And then how many z's are you left with? You're left with 7 of them. And so that's where we do the subtraction of our exponents for that property. Okay? So that takes care of the brief discussion. Okay, this is a good one. We need to make a note of this. Anything to the 0 power equals 1. So anything to the 0 power is equal to 1. So we'll do an example. If you have 5 to the 0, what's 5 to the 0 equal to? 1. If you have x to the 0, x to the 0 is equal to 1. Anything to the 0 power is going to be equal to 1. Just memorize that rule. Okay? So anything to the 0 power is equal to 1. The other rule we need to discuss is the negative exponents. Negative exponents. Okay. So negative exponents. Have you guys worked with negative exponents before? I don't know if they teach that in pre-algebra at all. They might possibly, but if not, that's no problem. So the negative exponents come from this concept. If I have x to the 3rd over x to the 5th, let's say. Okay, so that would be my example of x to the 3rd over x to the 5th. If I were to do the, let's say, longhand simplification of it, okay, meaning, what I mean by that is just expand it out. X times x times x over x times x times x times x times x. So that's the expanded format, right? So I have 3 x's on top, 5 x's on the bottom. All right. When I go to cancel, I say, okay, this cancels, as Zach told us earlier, it cancels not to nothing, but it cancels to the number 1, 1, and 1. So I have 1 on top, and then on the bottom, I have x times x, so that's x squared, right? So that's a fine way to do it. That's the answer. So far we haven't discussed the negative exponents yet, right? But if we go back to our quotient rule right here, the quotient rule stated is that I subtract my exponents. So I would go x to the 3rd over x to the 5th would be x to the 3 minus 5. Therefore, I end up with what? X to the negative 2. So x to the negative 2 is my answer, but what do we know the other answer is without a negative exponent? 1 over x squared. So what we recognize then is what a negative exponent does is it is referring to the same thing as 1 over x squared in this case. And we'll do examples of this and hopefully clarify any confusion. But you can also think of a negative exponent as it either flips it from the top to the bottom or the bottom to the top, depending. Because another example would be if I had, let's say, 1 over z to the negative 3, if I was given that, the negative on the exponent is going to, if we wanted to write it without negative exponents, that's going to take this and flip it to the top, so it would just be z to the 3rd on top. Okay? So a negative exponent has nothing to do with the sign of the base, everything to do with whether it's on the top or the bottom. Okay, and we'll do some examples of that here right now, in fact. We'll get some of these in here. Okay, so let's do this. Let's evaluate. Okay, we're going to evaluate, which means we're going to simplify, however you want to think of it. So if I have, let's say, number 1, 3 cubed. Okay, would we expect you to know 3 cubed without a calculator and be able to actually write the answer? Yeah, 3 cubed is doable, right? Because it's a multiplication thing. 3 times 3 times 3. And so what do we end up with 3 times 3 times 3? 27. Okay, so that would be the expectation. Now, where do we get that from? Remember, all we just stated was 3 times 3 times 3, and then you do the arithmetic behind that. And you could say 3 times 3 is 9 times 3, which is 27. So you should be expected to know that. What about 4 cubed? Anybody know 4 cubed off the top of their head? 64, yep. And then 5 cubed is about as far as we go in terms of like immediate memorization, or that you should kind of know. 5 cubed. Yeah, oh. Yeah, 125. 5 cubed is 125. So those ones are good to know. If you need to do it out longhand, that works as well. Okay, what if I have let's go 1 over 2 to the negative 3. Put a line there. And they want you to simplify this down, okay? A lot of people make the error. They say, oh, a negative exponent, my answer must be negative. The negative on the exponent has nothing to do with the sign of the base, right? Nothing to do with the sign of the base. So if this is positive, which it is, if this is positive, which it is, what's my final value going to be? Positive. So all the negative on the exponent does is it flips it from the bottom to the top or the top to the bottom dependent. So in this case, 2 to the negative 3, is in the bottom. It's just going to move it to the top. And so it would be 2 to the 3rd. 1 over 2 to the negative 3 is the same thing as 2 to the 3rd. And then we need to simplify what is 2 to the 3rd. We should know that, and that is going to be 8 exactly. Okay? So hopefully with working with some of these, they'll start to make sense. Now what if we have negative 4 to the negative 2? Okay, negative 4 to the negative 2. This one gets a little tricky. Okay. Remember, the negative on the exponent, you're not going to go a negative and a negative as a positive. It has nothing to do with that, right? So maybe don't think about the negative for a second. What does 4 to the negative 2 do? It takes it from the top and flips it to the bottom. Makes it the reciprocal, right? So this would be 1 over 4 squared. Okay, so it makes it its reciprocal, 1 over 4 squared. Now, we still have the negative component, so I'm going to bring the negative down. That's still there. And then we have 1 over 4 squared, which we should be able to simplify, which is 1 over 16, right? So now we have negative 1/16. Now, some people say, shouldn't that be positive because it's getting squared? Let me show you. This is a classic. Negative 4 squared or negative 4 squared. Two different writings of it, some different notation. Okay, what most people say is a negative being squared will turn into a positive because a negative times a negative is a positive. However, in this case, is the negative getting squared? It actually is not. Is the negative being squared here? Yes. So in this case, it's negative 16. In this case, it's positive 16. So you have to make a note of that. That'll come up. A lot of people get it wrong because they're just thinking the negative is getting squared. But since it's not included in the parentheses, only the 4 is getting squared. Technically, what's going on here is this is like a negative 1 times 4 squared. That's actually what's going on there. Is a negative 1 times 4 squared. We just don't write that. So that's why in the parentheses, that negative does get squared, and that will be a positive 16. Same thing going on here is that negative is not being taken to the exponent of 2 at all, and so it does not get, does not turn into a positive. Okay, let's do this one here. Just got a couple more. Let's say I have the square root of 81. You guys probably have all worked with square roots or should have worked with square roots. If not, let's do a brief review. What a square root is asking is what multiplied by itself gives you that value. So when we say the square root of 81, we're asking what multiplied by itself gives you 81. Usually at this stage, most of us are pretty familiarized with this scale.
9.
9, yeah, you bet. Square root of 81 is 9. Okay, you should have many of these memorized. So if I gave you, usually people are comfortable up to 144, usually. What's the square root of 144? 12, okay, good. I usually encourage people to memorize up to, all the way up to like 20 squared, which is 400. And so that way when you see ones like this, what's the square root of 225? You're able to identify that that is 15. Yeah, so I usually encourage people to memorize more than just up to 144, but that's usually in elementary school where you have done your times tables up to that value. All right, so then what happens if we have this, number 7, a negative square root of 36? Now it's important to make a note, where is the negative, on the inside or the outside? It's on the outside. Yeah, if it was on the inside, we would actually jump into the imaginary set of numbers, which we're not going to deal with right now. So since it's on the outside, we just have to say, okay, I'm not going to worry about that except to put it as part of the answer, which is important. But then you just say, what's the square root of 36? 6. So that's pretty straightforward there. So you won't, don't worry about the negative when it's on the outside. And then, let's do this one. Let's say we have a negative 1/5 squared, like that. We just kind of talked about this a little bit over here. Not quite the same, but let's start with the concept. Is the negative getting squared? No. The negative is on the outside, so the only thing that's getting squared is the 1/5, right? So our final answer is going to stay negative. And then what's 1/5 squared? 1/25, because you go distribute the exponent in, and it's 1 squared and 5 squared. And 1 squared is 1. Okay, sometimes people might make the error and call it 2. Don't do that. Okay, I'm going to pause here. Here's what the expectation is. Even if you only have 4 minutes, 3 minutes, 2 minutes, the expectation is pull out, and actually I think you have 5 minutes. You're going to pull out your homework and work on your homework. If you're all done with 1-2, what can you start working on? 1-3. Is 1-3 due tomorrow? No. Is 1-2 due tomorrow? Yes. So the expectation is you pull out your book, pull out your homework, and start working. Okay, and then you do not pack up until the bell rings. When the bell rings, then you're going to be dismissed. Yeah,
I have a question on one.
Okay, yeah, I can help you in a second here.
What if you already finished?
You finished 1-2 and 1-3.
We finished 1-2.
Oh, well, great. You can start on 1-3. That's awesome. Yeah, just work on 1-3. And if you're all done with like everything that's like possible you can work on, that's great. You can pull out a book to read or sit quietly or help those that are struggling through this experience.